Okay, so this is a practice problem for speed, frequency, and wavelength, and I've written the equation for the speed or velocity, only pertaining to light though, in this case. So this equation is referencing the speed of light, which is 3.00 times 10 to the 8th, I believe. So the equation is the speed or velocity, symbolized by v, equals frequency, symbolized by the f there, times wavelength, symbolized by what looks like an upside down v. It's got a Greek name, but so the speed or velocity is in meters per second, the frequency is in units called hertz, and then the wavelength is in meters. So we're going to be using that for the next practice problem. So the question is, what is the frequency of a mechanical wave that has a velocity of 1.77 meters per second and a wavelength of 12.05 meters? So we're going to be using the equation from before. And since you're solving for frequency this time, what you want to do is you want to rearrange the equation. You can do this before or after you start the problem, but oftentimes it's easier if you rearrange it beforehand so you don't have to do it when you've already written the numbers down. So this equation has just been taken and moved around a bit so that we're solving for f now. So it's frequency as a function of speed or velocity over wavelength. So what you're going to do now is, using our rearranged equation, we're just going to take the values from the original question and then plug them into the equation. So our frequency is going to equal 1.77 meters per second divided by 12.05 meters. And that's going to equal this decimal here, but because significant figures, each of these only have two decimals over here, the 1.77 and the 12.05. So this is going to simplify to two decimal spaces. So frequency in this case is going to equal 0.15 hertz.